Hey, what's going on, fellas? It's just a quick little update from Muhammad, who is dying to find out what the hell's going on over here. So, essentially, this is how far I've come along. Everything went great so far, except for one unfortunate event. When I went to tighten the canisters, I didn't tighten up quite in the position I would like them to. When I tightened them on the bench and assembled some things, I had a different feel for how tight they were, but once they were mounted in place, I didn't like how they felt. They had a lot more rotation left in them once you had a good footing to turn it with. So I'm going to have to extend the front of this cage out a little bit here. This is basically a 10,000 watt electrolyzer. It can do a lot more than that, but I am limited by how much power I can put into it. So let's just do a quick little walkthrough of what we got going on. Essentially, to start off with here, you'll notice an air compressor. This is to add a little bit of air into the fuel stream to kind of knock back some of the detonation characteristics of this gas. I don't want a bunch of flashbacks and all that, and I'm also interested to see what type of flame we can get with entrained air, because I got a feeling it would behave more like a propane flame versus just this highly explosive mixture of detonating gas. So that's the purpose of the air compressor. We're going to be doing some exotic combustor testing with hydrogen flames. There's a lot going on there. For the most part, I needed a huge amount of oxyhydrogen gas to do that. And this is the machine that's going to pull that off. So let's do a quick walkthrough of what we got going on here. To start off, the main turbocharger of this whole thing is this dual pump system that you see here, that is going to force electrolyte into this massive electrolyzer. This is an 81 plate cell, I believe. I'll have to double check the specs, but it's going to be running hot at about 3 volts on full power. This is not an efficiency machine. This is a hot rod. This is like a dragster engine. This is not a Geo. So, for the most part, we've got a lot of plumbing going on here, and some of this is to mitigate some of the bubbles and foam. I've got a screen in here to trap some of the entrained bubbles out of the flow stream. Essentially, I'm not finished yet, by the way. I had to go get more parts, in case you're wondering. So, what's going to happen is the electrolyzer is going to discharge gas and electrolyte in an entrained flow up these side rails, and that's going to fall down into this tank. Now the fluid level of this tank is going to be kept about right here. Bubbles don't like to pass through screens, so hopefully most of the bubbles will be separated at this point. If not, no big deal. I'm not too worried about it. I may test different levels to see what's best for bubble separation. But for the most part, from there, the fluid will travel down and into these intake ports here, into the electrolyte reservoir. This is the main reservoir right here. This here is to separate the bubbles out of the gas and to mitigate any foaming issues we may have, which takes us to the next part. This is a foam trap. I have one of these on my hydrogen torch that I use for brazing. And essentially the way it works is the gas from the electrolyzer travels along this tube, comes up the top here, and falls down that gray tube into the pit here. And the water level in this tank is going to be the same as this tank, because the bottom of it is connected directly to the reservoir right here. So that way any foam and spatter that makes its way out of this portion of the system will end up in this tank, and then it'll turn back into fluid, the foam will, that is, and it just ends up right back in the electrolyzer. It will auto level itself out, just kind of like a water level. So from there, the gas is ducted into this massive bubbler that is used to scrub the gas a little bit, and it has a diversion pad on the bottom of it, and in this pad are some valleys that are cut. There are 2 cross cuts, and there's some circles on the top here, and a quadrilateral radial array there. Can't really see them. That stainless steel screen is meant to turn them into micro bubbles. There's also one on the bottom. So that way we ain't just got these big stupid bloppy bubbles traveling up through the bubbler. The smaller the bubble, the better sodium hydroxide spray will be washed. And there is a little bit of electrolyte that makes it to this point. So you want to wash that out of the system. And essentially from there, the gas will discharge into a stainless steel, the entire thing will be stainless steel flashback arrestor. Inside the flashback arrestor will be stainless steel wool or bronze wool. I'm not sure yet. I have both items on the way in the mail. And I have seen where stainless steel wool is a highly effective flashback arrestor. My friend Daniel 2008C, who builds electrolyzer torches, has used bronze wool very effectively in the past. So I'm going to be looking into those 2 avenues with some type of metal container flashback system. And also, as I said, air will be injected into a T at this point right here to entrain with the hydrogen gas, the oxyhydrogen gas, so that it isn't as explosive, so that I'm not constantly flashbacking and all this stuff. Plus, I want to see how well it will work to make a more usable flame. Like, it would be so cool to have like a massive rosebud torch off this thing by pumping some air into it. Because hydrogen alone requires a very high velocity flame, so you end up stuck with all these little tiny needles just sticking out of the nozzle like little lasers. I think entraining some air in the gas stream is going to give us a much more usable flame and spread that fire out to a more fluffy flame instead of these laser needles like you see all the time. So I'm really looking forward to that idea. I can't believe all these years I've never thought about doing that. I've mixed oxyhydrogen with everything under the sun except for air. I've actually even hooked one of these pumps up to an electrolyzer and put the electrolyzer under vacuum, thinking it would increase output. Well, it doesn't. It does for a second, of course, but it hits an equilibrium. But I never thought about adding a little bit of air to the oxyhydrogen to produce a less explosive but larger volume gas. So that's one thing we're going to try. We're going to do some stuff without that also. I just wanted to have it because our goal here is to get 30 liters per minute. So any of you guys who have ever achieved this with electrolyzer will probably have some input. Now let's talk about this electrolyzer pretty minute because it is pretty amazing. It's not totally finished, but it's close. And one of the cool things about it that I want to show you guys are these copper bus bars that go down the entire side of the electrolyzer end plate here. This end plate is just slapped up against a piece of steel and right into the gasket show. There's no void in there like you see on some of these typical units. So the copper bus bar evenly distributes the electricity through the stainless steel, because stainless steel, as we've seen in my previous video about this, is a horrible conductor. It's like a 3 on the copper standard, which is just drastic, and you'll get some significant zone heating that can cause problems. So you see here we have a jumper wire that is connecting this bus bar to this bus bar terminal. There's another bus bar on this side, and this is the lug where we will be connecting the 250 volt DC power. I'm very lucky. I live in a rural area and they've got some really high voltage out here. So I'm pushing 253 out of the wall, and I'm expecting at least a 3 volt diode drop. So we have the same setup over here. Another copper bus bar. I've got some dielectric grease on there. I hope that wasn't a dumb move. I'm not going to do any more securing, but you see we have the other jumper. And there is a straight bore all the way through The center plates, the center section of plates has smaller holes than the outer ones. The biggest holes are about that big around, and the smaller holes are about like that. And we also have a cooling system here. This is the coolant discharge. The cool fluid from the radiator will discharge here and hopefully be pulled right into the electrolyzer. And the fluid is pulled from the reservoir right here down into the intake of the pump and going up into the radiator here. I'm not sure what I'm going to do for a fan yet because we don't have very much time. I may simply set a squirrel cage fan like that in a convenient area. That's what I do with my torch over here. You can see I've already got it kind of set up. This thing's an experiment in the making still. One day I'm going to put it in a real box. But it is, that's what I do. I've got a radiator on the back and I just set a fan by it. This thing here can do 5 liters a minute on, I think it's 2,000 watts. I'll have to double check that. It's got the same setup with the bus bars and jumper wire. This one here is a little bit more elaborate. It has extended plates with cooling fins sticking off the side. There's a gap in there, as you can see. And there's fans on both sides to kind of give me as much cooling as possible, because like I said, I don't build efficient cells, I build hot rods. These are like dragster engines. That thing can crank 1,000 amps of Faraday electrolysis power through it. A lot of people get mad at me when I say that, but they really don't understand Ohm's law and the equations used to determine it if they don't believe me. If you have 3 volts passing from point A to point B, and you're pulling like 2,000 watts, if you divide 2,000 by 3, what do you get? I mean, I can't think that out in my head. I think it's 333, so 600 and, let's see here. Oh man, I'm feeling stupid today. Okay, yeah, 666. Bad number, Bob. Damn it, I knew it. So, I don't know why I got off on that tangent anyway. And then all of a sudden, Satan's in the picture. So this is what we got. This is where we are. I've got a lot to add to this thing yet. I'm also going to be taking some pieces of plexiglass and sticking panes of plexiglass in between every one of these rails and just giving it a little splosh of glue here and there to hold them in place. I may do something a little bit more elaborate, but I doubt it. I've never had any problems with these gaskets pushing out in the past, except for one time when I overran the cell, and that was that unit over there. So because I intend to just kill this thing if I have to, I think I'm going to go ahead and cut some strips of plexiglass and kind of line these certain areas here to give them gaskets something to push up against. I don't know yet. I'm thinking about it. I've got the material, but I just don't have the time. So I think that about covers everything. Like I said, none of the power electronics are in yet. I've got to mount the diodes. I've got some pieces of wood for that. I also want to point out this stone's going to be taken out of here. These are just props till I get the plumbing hooked up, and I'm going to put some actual steel brackets holding this stuff up. This cell is sitting on 2 pieces of cherry wood to act as a dielectric. We cannot have these 2 end plates electrically connected in any way. I've already checked them with an ohm meter, and they're as dead as a doornail, just the way we want it. I've got some more wood over here, also Muhammad. I'm going to be cutting this wood here for mounting the diode and the input bus bar and all that stuff, because we need something that's not conductive, and cherry is a very hard material. It's they use it for trim a lot, and it's really good for stuff like this. It's hard as steel. Like, you can't break that stuff if you try. If you try to put it in your hand and step on it, you'll rip your wrist off. So very tough stuff. But this is where we're at. I would really like to consider possibly renting a generator to run this thing, because it'd be a shame to only put 10,000 watts into it, and I guarantee you we can do way more than that. Guaranteed. This thing's got some cooling on it. I mean, we could really scream some power into this thing. I don't know how much. I don't want to speculate, but I would say we could do 20,000 watts, no problem. Based on past experience. I mean, I can pump 2,200 watts into that thing, and that's just a little midget. It gets hot when I do it, but it can be done. I'm not worried about blasting the plates or nothing. By the way, this is 304 stainless, guys. This is not 316. And everyone gets on my case about it. What you guys don't realize is, over time, periodically, I reverse the polarity on my plates. And what that does is literally reverses any corrosion process that takes place. The cathode will literally blast off most of that stuff, almost all of it. It'll have a light tinge to it, but there is no corrosion buildup. And this comes from experience of running these cells here for years. And I have always done that. If you reverse the polarity periodically, then you don't have to worry about that. Let me see if I've got some plates here that we could examine that have just been worked to the ground. Here's one. Now these here are not 316. I'm almost 100% sure of that, because there's no way the source of this metal would have paid for that. This is air duct stainless steel. So if you think they use 316 for air ducts in a hospital, I highly doubt that. There's no way that it just can't be. There's one right here. Let me see if this is magnetic. Now, if the stainless steel is magnetic, then yes, it gets in pretty bad shape. I'd almost say this is a magnetic plate, which means it is not 304. Yeah, it's a guy I got to do to get a good magnet. Okay, this is not 304 stainless. This is. And as you can see, the magnet literally just does nothing. It won't stick to it. So let's check that end plate that I just set down. I'm losing it here. Okay. Wow, that's pretty amazing. And this was a good plate. I can't believe that. This is a neodymium magnet. I might want to add. I might want to mention that. Let's get a regular magnet, because that kind of gives you a false representation. This thing is strong, dude. However, that did not stick to that right there at all. That's 304. Okay, this barely sticks. Not even enough to hold itself, but nonetheless it sticks. Let's see if I can. Yeah, it won't stay on there. I'm not getting really hardly anything. I don't know that I would tell you that was magnetic. There's definitely a difference in these two grades, for sure. Sorry. So this whole theory about, like, I'm getting a lot of flack already about the 304 stainless. I've got a couple of efficiency guys on me. Man, I've got a whole stack of these plates somewhere. I'm really killing this video. All right, I'm shutting up. Here's another one. This is the same stuff. But you see, this is what you get. It's just a light tinge. There's nothing on there that's significantly reducing efficiency. And I know that because what you're looking at here, fellas, is iron plates. That I did an iron plate cell years ago. And they're slightly more inefficient because a continuous process takes place where you have oxidation and reduction with the iron. But nonetheless, it's very doable. They used to do this in the 1920s, and they last for a long time. They don't just rust away the way you think they would. For the most part, the reason for that is because iron does not like to rust in a base or a high pH solution. Anything over 8.3, and it's all you can do to get iron to rust. So that's another reason why iron plates are a very applicable idea. They make a pretty nasty electrolyzer tank, but it works just fine, if that makes any sense. So there you go. This stuff here, guys, does take a magnet, and what I was doing was periodically reversing the polarity. A lot of this sheen that you see takes place when the cell is shut off. A lot of the times when you turn it on, it'll blast it right back off of there. Damn, have I been yapping for 21 minutes? I gotta shut up.